So rules for calculating probabilities. As you just saw, one way to calculate probabilities is to literally count up the number of times an outcome occurs and divide it by the total number of outcomes. But oftentimes you'll be interested in probabilities that you can't necessarily count. So one of the ways to get to probabilities is to calculate them using a set of rules. And in this class, we're going to be looking at a somewhat simplified version. So if you look at the readings, you'll see they go into a bit more depth than we do here. But this is more to illustrate some of the different ways of getting probabilities and to just get you guys thinking about probability in this way, more so than it is for you to be able to calculate every probability out there. All right, so one example of a rule for calculating probability is in thinking about a single trial with a single outcome, you can find the probability of some outcome not occurring. And to find the probability of an outcome not occurring, you do something called the Converse Rule. And with each of these, I'm going to briefly describe it, then we're going to head back over to the document camera and I'll go through examples of each one with my little crayon pot. All right, so another rule for calculating probabilities is something called the addition rule. And the addition rule will give you the probability of either getting one outcome or another outcome. So with these, the Converse rule could tell you, for example, what's the probability that you'll pull out a crayon and, it's going to be not red. Oh, all right, it's purple, so it's not red. The addition rule would be, what's the probability of getting a crayon that's either red or green? Let's see. Well, this one's red, so we'll find out the probability of that happening in just a little while. There are also rules for calculating probabilities that occur across multiple trials. So multiple trials being if you were to draw more than one crayon out of the pot and get an outcome for each of those draws. So if you're looking at two or more outcomes, the multiplication rule can tell you the probability of obtaining one outcome and then obtaining another outcome in the second trial. So as an example, if we wanted to know the probability of drawing a green crayon and then another green crayon, we'd be drawing one crayon, happens to be yellow, putting it back and then drawing another crayon. This one happens to be green. But we didn't get a green crayon and then a green crayon, which is the probability that we were thinking about there. One note here, and something that's important, is that if you're looking at the multiplication rule and you're thinking about the chance of getting one probability and then getting another probability, the outcomes have to be independent. And what this means is that the events that happen in the first trial don't have any effect on the events that happen in the second trial. And so the reason that I made a point to put the crayon back after I did the first one is that if I were to take one crayon out here, all of our probabilities would change. Because now we're not looking at outcomes out of 12 crayons, we'd be looking at outcomes out of 11 crayons if I left this one out of there. So by putting it back in, I'm restoring it to what it was before and making sure that the events of the first trial didn't affect the probabilities of what would happen in the second trial. So again, just to sum up here, if you're going to use the multiplication rule and look at the probabilities occurring across two or more different trials, it's really, really important that what happens in one trial doesn't affect anything that happens in another trial. In other words, they need to be independent. All right, so with that, I'm going to go through these with more concrete examples now, so we're going to hop back over to that document camera.